Hey Honors Algebra 2 and Algebra 2 students, I am going to do a video actually over 3.3 and 3.4. I'm going to kind of put these together. So 3.3 is all about completing the square. So what I'm going to have you guys do is just kind of grab out a sheet of paper, or if there's some blank page on any of your student journals, you can use that. I just want to go through an example of completing the square. It's not a process that we're going to use a whole lot, but I want to at least show you, and that way you can kind of write down the steps and have it. So go ahead and grab a sheet of paper. If you need to pause the video, pause the video. All right, so I'm going to show you that we're going to start with an example. And so what we're going to be talking about in this section is, so I'm going to combine completing the square and quadratic formula. And so I'm going to show you how to solve quadratics using those two methods. So I mean, completing the square is something that you probably learned in Algebra 1, maybe. It's just not a process. Once you know the quadratic formula, it just seems like something that we don't tend to use as often. Anyways, the first step, if you remember, is to move c to the other side of your equation. So remember, c is your constant term. So in this example, I'm going to go ahead and add 6 to both sides. All right, number 2, you're going to divide by the coefficient, which means the number in front, of your x squared term. So this only applies if you have a number that's in front of your x squared. If it was just 1, then obviously you can omit this step. So what I'm going to do here is I'm going to divide everything by 2. All right, step 3. You need to find b over 2a and then square it. So this is kind of a weird thing. So it looks like that's that formula for the vertex, right? So what we're going to do is we're going to kind of use that same idea. So b would be 8 over 2 times a in my equation now would be 2. So I get 4. And then if I square it, I get 16. So once I find b over 2a and then square it, I'm going to add that value, and it says add, to both sides of my equation. So it's going to look like this. The reason we do this is because our original function wasn't factorable. And so completing the square is kind of an in-between type method. So like it's in between kind of like factoring and quadratic formula almost. And so what we're really doing is we're kind of making this a factorable equation. All right, so next, what you're going to do is you're going to factor your equation. So now, by adding this 16, you made this factorable. And I can just simplify that side. So what I want you to remember here when you do completing the square, it always factors into the same pattern. What I mean by that is we call this a perfect square trinomial. So that's the one where it's like the same parenthesis twice. So it'd be like x plus 4 times x plus 4. So this occurs every single time we do, that's why we do the completing the square. So it makes this into a perfect square trinomial. So if you know that that's kind of the expectation, what I do is I think, okay, well, what did I take the square root of? How do I take the square root of x squared? I get x. I take the square root of 16, I get 4. And then whatever this middle term is becomes my middle term in my parentheses. So basically I take the square root of the first term, the square root of the last term. That's how I get those two values. And then this sign gets dropped down. So once we factor, all we're going to do is solve. And we're going to solve by that square root method. So now what we actually did is we took this standard form equation and we wrote it into vertex form. So some of you are asking, I know in my classes we're asking about like how to switch from one form to another. So this is the process from taking a standard form equation into a vertex form equation. All right, so since we're solving, we're going to square root both sides. I get x plus 4. Don't forget your plus and minus. I get root 19. And then, of course, I'm going to subtract 4 from both sides. So this would be my solution overall. So that's one example. It's probably one of the more, I guess, more challenging examples because of the coefficient in front of the x squared. But like I said, this is more of just something I wanted to show you, not necessarily something that you're going to be, graded on, so to speak. at least not in my classes. All right, I do want to show you though, since we're going to get into quadratic formula, I want to show you where the quadratic formula comes from. So we're going to use, again, you may want to grab another sheet of paper. So what I'm writing here is you're going to use completing the square to find the quadratic formula. So the quadratic formula, you know, like how did someone create that thing, right? Well, it is derived by starting with your general standard form equation. And what you're really doing is you're taking this and you are solving for x. So we're going to use completing the square and we're going to solve it. So we're going to take the standard form equation and we're going to kind of work down through the steps and we're going to eventually solve for x. Just like we did in the last example with the numbers, this time we're going to use a, b, and c. The steps are still the same. So if you remember, the first step of completing the square is move c to the other side. So that's what I'm going to do. So again, obviously we're dealing with a's, b's, and c's here and not numbers because I want to show you that this works for every problem. All right, next step. If you remember from the last section, you're going to divide everything by that coefficient of x squared. So I get x squared plus b over ax equals negative c over a. Okay. After that, what you're going to do is you're going to take b over 2a and you're going to square it. So b over 2a, so my b term is b over a, and my a term is 2, okay? And then I'm going to square this. So be careful. There's a little math involved here, right? So b over a divided by 2. b over a divided by 2. Remember how to divide fractions. You change it into multiplication, and then you multiply. So essentially, when I take b over a divided by 2, I get b over 2a, which is a little weird, right? Because it's kind of back to where we started. That's okay. And then we're going to square this. Remember, so it's b over 2a squared and add it to both sides. So I did. Here's my b value, here's my a value. I simplified, and now I'm squaring it. And now I'm going to add this to both sides. Oops, there's no x here. b over 2a. All right, so I added that b over 2a squared to both sides. All right, so the next step would be to factor. Remember what I told you. It factors into a perfect square trinomial. So you take the square root of the first term and the square root of this last term. Well, it's being squared, so the square root would be b over 2a. And then whatever this sign is gets dropped down. And then over here, what I'm going to do is I'm going to go ahead and I'm going to kind of separate this so you don't get confused. I'm going to do a little work on the side here. So I got negative c over a, and I'm going to add it to, let's square this. So I get b squared over 4a squared. So if I square the numerator and square the denominator. All right, let's combine some like terms. Let's add those two fractions together. So a common denominator between those two would be 4a squared plus 4a squared. So I'm just gonna scale up this fraction. So I'm gonna multiply by 4a. So I get negative 4ac on top, and then the b squared. So now if I add my two numerators together, I get b squared minus 4ac. You might see where this is going, right? So this is that part of that quadratic formula. So what I just did here was I just added those two fractions together, and it required a little bit of work, right? So I had to square that, and then I had to actually, old school and come up with how to add some fractions together. So anyways, I get b squared minus 4ac all over 4a squared. Okay, now let's solve. We're going to square root both sides. So I'm going to get x plus b over 2a equals, don't forget your plus or minus. Since this is a fraction, when you have a square root of a fraction, you take the square root of the numerator and the square root of the denominator. And since the square root of the denominator is a perfect square, you can write it as 2a. And then the last step would be to go ahead and subtract this b negative, or this b over 2a, subtract that from both sides. And then the very, very, very last step, this is actually your quadratic formula. What the one you probably remember though is, since these are both 2a's, you can write it as one fraction. So this is where you get the negative b plus or minus the square root of b squared minus 4ac all over 2a. That's where the quadratic formula comes from. It comes from taking your standard form equation and completing the square. And I know that this isn't something I necessarily would ask you on a test, but I wanted you to see where this is coming from so that you understand that this quadratic formula isn't something that's just someone created out of the clear blue sky, that it's something that is derived by mathematical processes. All right, I'm going to have you move ahead to page 62. So we're going to skip ahead to page 62. So this is on 3-4. So I kind of already did 3-3. So we're going to skip ahead to 3-4. And this is all about quadratic formula. So again, if you don't have it memorized, and that was the one we just created, the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So you do need to have that formula memorized. It will not be something that we give you on the assessment, but it's a good, you're going to need it anyway for like every other unit that we do this year, or at least a lot of them. And then on to obviously later on when you get into honors pre-calc and whatever else you take, calculus and so on. The other vocab word here is called the discriminant. The discriminant actually refers to a part of your quadratic formula, and it's the part that's underneath the radical. So your discriminant is the part that says b squared 4ac. A lot of people get that one mixed up because they put the square root over it. So be careful, it's not the square root of b squared over 4, or b squared minus 4ac, it's just b squared minus 4ac. Let's do some quadratic formula ones. This is probably ones you're a little bit more used to. I saw quite a few people already doing some problems with the quadratic formula, so obviously you're a little bit more familiar with this. So, you know, obviously when you go to practice, I would maybe look at the ones that are the most challenging if you feel really comfortable with this stuff, and then do those. You know, there's no sense of doing a million problems with the quadratic formula if you know how to do it correctly. All right, so your rule of thumb in terms of like steps, if I had a quadratic in front of me and I asked you to solve it, your first thing would be to try to factor. And when I say that, I mean check for a GCF. That's always my first step. And then if it's, you know, a difference of two squares, depending on what type of problem it is, but then you want to look for, if it's a trinomial, you would factor with the two parentheses. If it's a difference of two squares, then it would be, you know, one parentheses positive, one parentheses negative. But anyways, you always want to try factoring first. Remember, if there's no x term in your problem, so in other words, if it's x squared, like plus 28, for example, then use the square root method. That will always be your best bet, or if your equation's in vertex form. If you're in vertex form, or if you have no x term in the middle here, then you want to use the square root method. And then lastly, if neither of those things work, I always resort to the quadratic formula. So completing the square doesn't really make my list. It might make yours, and that's fine. It is a way to solve a quadratic, and if you like it, use it. But this is generally the things I try when I ask to solve. So I try to always try factoring first. It'll be your quickest and probably the one that's going to be the most useful. And then watch out for the whole square root method if there's no x term or if it's in vertex form. And then last but not least, I try quadratic formula. What I don't like to see is everyone using quadratic formula every single time, because I need you to understand that there are times when factoring is better. And so I do want you to kind of try to factor this. All right, so I'm going to pull this one. I have this example. Let's go through it. This one, it's not factorable. So I'm trying to think of numbers that multiply together to give me 28, but add to 10, and I don't have any. So I'm going to do negative b plus or minus the square root of b squared, which is 10 squared, minus 4 times a times c, all over 2 times a. I would like to see this step. So like if you were on a test, even if it's on big ideas and you're just clicking a box to the right answer, on your paper I want to see this because it is really easy using the quadratic formula to make a mistake. And so what I'd like to look at in what I would hope to see on your paper is if you have this written out and then you make a basic computational error, that's a way different mistake than, getting the whole problem wrong. So the more work you can show, the better. I always kind of do the discriminant part. So I do 100 minus 4 times 1 times 28, and I get negative 12. All right, remember, a square root of a negative means that we're going to have an imaginary solution. So what I want you to remember here is root 12 is like saying square root of negative 1 times the square root of 12, which we know can be broken down into 4 and 3. So when you rewrite this, the square root of negative 12, you never want to leave the negative underneath the radical, would be 2 root 3 I, and then over 2. All right, pay attention to this part. If you haven't paid attention to anything else, pay attention to this part. This is why, and only when you can simplify with the quadratic formula. What I see as the most common mistake is that people will simplify, like they'll say negative 10 over 2 is negative 5, and then they'll write negative 5 plus or minus 2 root 3i. This is not correct. And the reason why is because not just the negative 10 is being divided by 2, but this is as well. And so you have to remember that both of these values are being divided by 2. So if you're going to simplify, you have to simplify both. So for example, negative 10 over 2 does reduce to negative 5, but 2 root 3i over 2, the 2's would cancel, and I'd be left with root 3i. So that is kind of how you use the quadratic formula in a nutshell. All right, let's talk about discriminant, which is on the next page. Sorry, but my dog is barking. He chased a turkey earlier, so he's all excited. Okay, discriminant. Remember, that's that part underneath the radical. What the discriminant tells us is, so if you find your discriminant, there's basically 3 scenarios here. So if you find the discriminant, it's an easy way to kind of assess how many solutions you're going to have without having to do like the whole quadratic formula. So if the discriminant is greater than 0, which means it's a positive number. Jack! If the discriminant is positive, you're going to have 2 solutions. If the discriminant is 0, it means your graph is going to touch the x-axis but not pass through it, which means it's going to bounce off. And so what that means is you're going to have 1 solution. And when the discriminant is less than 0, which means it's negative, that's that underneath the radical would be a negative number. That means that you're not going to have any x-intercepts. So you're going to have 2 imaginary solutions, but no x-intercepts. And so the relationship between solutions and x-intercepts, you can have solutions in every scenario. 2 real solutions, 1 real solution, 2 imaginary solutions. But that doesn't equate to the fact that you could have that number of x-intercepts. 2 real solutions will give you 2 x-intercepts. 1 real solution will give you 1 x-intercept. Imaginary solutions will never give you x-intercepts. So whenever you have an imaginary solution, you know that the graph is not touching the x-axis. So I'm going to give you an example. I'm trying to pick one that's a little bit more challenging. So it's not in the, traditional form. So I'm giving you this equation, and I said, let's find the discriminant and tell me what it means about the number of solutions. So in order to use the discriminant, you really need your equation in standard form. So what I'm going to do is I'm going to distribute the y, and then I'm going to solve my equation, I'm actually going to just set it equal to 0. So at this point, you could there's other ways to find how many solutions. Like if this were on a standardized test, for example, and they wanted to know how many solutions the graph had, I would graph it on my calculator, right? If it has, If you want to know how many x-intercepts it has or how many solutions, if you graph it on your calculator and it touches your x-axis twice, then you know you have 2. And so that would probably be the quickest way. But let's say you didn't have one and you wanted to just use the discriminant. So b squared minus 4ac is our discriminant. Let's see. b is 1, a is 1, and c is negative 3/4. So this is 1, and this is negative 4 times negative 3/4 is positive 3. So my discriminant is 4. And to be honest with you, I don't care what the discriminant is. What I'm looking for is it positive? Is it 0? Or is it negative? In this case, obviously 4 is a positive number, which means I'm going to have 2 real solutions. I'm also going to have 2 x-intercepts. So by knowing that this is a positive number, that's what that tells us. All right, let's do some more. I'm not going to do everything on this next page. We're on page 64, but I want to do a few of them, and then you guys can do the rest. So I'm going to do number 3, 4, and then I'll do the big one, number 7. Right. Number 3 says, solve the equation, use the quadratic formula, use a graphing calculator to check your answers. So I just want to show you that you do need to have your equation in standard form in order for you to use the quadratic formula. So I'm going to move everything to this side of my equation. So I'm going to add 4z to this side, and I'm going to add 3. You don't have to make it, like you could have just added 7z. I don't like it when my number in front is negative. I don't know, it's just a pet peeve of mine, I guess. All right, so anyway, I did that way. So if you did it the other way, we should still get the same answer. So negative b would give me positive 7, at least in mine, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So again, I would really, really, really like to see a little work on here. Again, I think it would benefit you in the long run, because if you make a simple mistake, I can give you some partial credit. All right, 49 minus 4 times 3. And I just type it in my calculator exactly the way it's written. 49 minus 4 times 3, and I get 1. And then the square root of 1 is just 1. So my 2 solutions are x equals 7 plus 1 is 8. 8 over 8 is 1. And then 7 minus 1 is 6. And 6 over 8, if you reduce it, would be 3/4. So these are going to be my x-intercepts. They're also going to be my solutions. All right, let's do another one. This one says find the discriminant. So in all of these examples, you're finding the discriminant. So again, remember the discriminant is b squared minus 4ac. So this would be 34 squared minus 4 times 1 times 289. So grab your calculator. 34 squared is 1,156. And 4 times 1 times 289 is 1,156. So I get an answer of 0. So this 0 tells me I'm going to have 1 real solution, 1 x-intercept. And so that's what that value tells me about my equation. All right, next one. This one is kind of a story problem. I always figure it's probably good to kind of practice these story problems. So it says a baseball player hits a foul ball straight up in the air at the height of 4 feet off the ground with an initial velocity of 85 feet per second. Write a quadratic equation that represents the height of the ball t seconds after it hits the bat. So the height of the ball has to equal. So remember, these are like those velocity questions. So the initial velocity is always going to be negative 16. So when we talk about like the hitting of a ball or like throwing hitting a hockey puck. I'm trying to think of some of the other ones we did. Shooting a flare. So we're going to use H's and T's. So again, I'm just going to use my standard form equation. It says it's at an initial velocity of 85 feet per second. So that's what goes as your T term. And then the 4 feet off the ground would be your constant term. So again, this is just kind of how the numbers in the equation would look. So now the that comes into play is when is the ball 110 feet off the ground? Explain your reasoning. So 110 feet refers to the height. So what you want to do is you want to plug 110 in for the height. So I did that. And now I want to go ahead and solve for t. It's asking me when. So you know your answer has to be a unit of time. So what I'm going to do is I'm going to go ahead and solve this equation for t. So my first step is to set it equal to 0. And then it doesn't really look factorable. Yeah, it's going to be a little bit ugly. So I am going to not even bother with factoring. I'm going to go ahead and use the quadratic formula. So x equals negative b plus or minus the square root of 85 squared is 7,225 minus 4 times a times c. Make sure you get everything in there. And 2 times a. Okay. I'm going to type all that in the calculator, and when I do that, I get 441, and I get negative 32 on the bottom. So 441, I believe, is a perfect square. So square root of 441, yeah, it's 21. So plus or minus 21 over negative 32. So let's give me my two answers. So negative 85 plus 21 divided by negative 32 gives me 2. And then negative 85 minus 21 divided by negative 32 gives me about 3.3125. So obviously not factorable because if we have that decimal. So it says, when is the ball 110 feet off the ground? Explain your reasoning. It is at 2 seconds and at 3.3125 seconds. Well, you might be asking, well, how is that possible? How can the be at the height off the ground in two different spots? And now I want to refer you to what a graph of a parabola looks like, right? So a graph of a parabola looks like this. So if I wanted to do a height of, what was it? A height of 110 feet. So let's say this is 110 feet. That means it's going to be at two different times, two different x values, where I'm going to have a height of 10 feet, which is why I get two different answers. So basically when the ball's on its way up and then when it comes back down. So after 2 seconds, the ball's on its way up, and then after 3.3125 seconds on the way back down, it's going to be at that same height. And so that's why there's two different answers for this one problem. All right, last question. The catcher catches the ball 6 feet from the ground. How long is the ball in the air? So this time we want to know if the ball, like basically if they catch it 6 feet off the ground. So when the height is 6, how long did it take the ball? So again, solve for x or solve for t because we are solving for our time, and you're going to use the quadratic formula and solve this equation again. But this time set it equal to 6. So I've got this. I'm going to use negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And I get negative 85. All of this, I did this in my calculator and I put the square root just to save a little time here. I got like 84.24 for that. It was not a perfect square. And so ultimately I get an answer of 0.02375, and then I get an answer of 5.28875. So basically I get two answers again. So it says the catcher catches the ball 6 feet from the ground. How long is the ball in the air? So what this is saying is basically that so remember the initial height was 4 feet. What this is saying, after like 0.02375 seconds, the ball was 6 feet off the ground. But if we want to figure out the total time the ball was in the air, it's going to be this last digit here. That would be the total number of time that ball is in the air. And so therefore, it's going to be in the air for approximately 5.3 seconds. All right, So I apologize for the length of this video, but we did cover 2 sections. So again, I would maybe practice the rest of the problems on the sheet. You can always go to Big Ideas and do one of the lessons there. Either way, come to class with any questions you might have. Thanks.